Hello, everyone! Welcome to the first lesson on programming with C++.
Since we will be learning C++ in this course, the first question that comes into our mind, what exactly is C++? C++ is a programming language. So the follow-up question that comes into our mind is this a language class?
Whoa, are we in the right room?
Pretty sure.
So, the next question comes, what is a language?
A language is a thing that helps us to communicate with other people, share our thoughts and feelings, and let the other person know what we are trying to say. So if you are trying to communicate with a person, you need to speak a language that the other person understands. Otherwise, your conversation will be something like this.
Hi, could I get 2 of those, please?
你要几个这个吗？
Yeah, hold on, I'll translate.
你要2个？
两? Wait, no?
不对。
So a language needs to have a set of words that is associated with the language. It needs to have a grammar, which is a set of rules that makes the language. And in order for the language to make sense, we need to follow those rules. And as a result, we can communicate with that language with the other people who understands the same set of rules and the same set of words. Now I think you all know that computers only understand zeros and ones. So if we want to communicate with the computer and make it understand some instruction that we are giving to the computer, then we need to use a language that the computer understands. And we cannot use our plain English language.
Hey, laptop, can you finish my math homework? It's due tomorrow.
0
What? That's not even words.
Does not compute. Please provide zeros and ones.
You only speak binary?
Yeah, that's true. Computers only speak binary. But obviously, we will not use zeros and ones to talk to the computer. We will use high-level programming languages like C++ in order to communicate our instruction to the computer. In the next video, we will talk about different levels of languages. But for this one, let us just focus on high-level programming languages, which are very similar to our normal English language. It also has a set of rules or grammar. It also has a set of vocabulary, the words that are associated with that particular language. And obviously, it helps us communicate with the computer.
So what is a programming language? Okay, so let's start with something very simple. A programming language is used to write programs. That's it. No mystery there. But now the real question is, what exactly is a program? A program is basically a set of instructions.
Think of it like giving directions. If I tell you, wake up, brush your teeth, make coffee, leave the house, that's a sequence. A program is the same idea, just written in a language that the computer understands. So when we write a program, we are not doing any magic or anything. We are just telling the computer, step by step, do this first, then do this. If something happens, do that instead. And computers are very obedient, but also very literal. They do exactly what you tell them, no matter what you meant. So it will just do the exact thing that you will write as an instruction in the programming language that you are using. It doesn't matter what you wanted the computer to do, but if you write something else, the computer will just do that. And that is the reason why programming is not just about remembering the grammar of the language. You will get to remember that as you practice. But once you know how to frame your logic, how to convert the step-by-step sequence that you have in your mind into a programming logic, then you already know how to write a program. And this learning will help you in the long run. No matter which language you learn in the future and how comfortable you become with that particular language, if you know how to frame your logic, then you can use any language anytime. All we are learning in this course is to convert the step-by-step process that we have in our mind into a programming logic using a particular programming language. For this particular course, it is C++.
All right, so now let's answer a very basic question. What is a computer? At its core, it's a machine that takes information, processes it, and spits out useful results.
At its core, a computer is actually a very simple thing. It does 3 things. That's it. First, it takes input, that is anything you give to the computer. Typing on a keyboard, clicking a button, uploading a file, scanning something using the scanner. All those are inputs. The next thing that the computer does is processing. This is the computer thinking. It follows instructions, makes decisions, does calculations, compares values, exactly what we tell it to do in a program. And finally, it gives output. That is what the computer gives you back. It can be a number on a screen, a message, a graph, a printout, and even an error. A small piece of program, that is a set of instructions that you will write in a particular programming language, C++ in this case, will also do the same three things. First, it will take in some inputs. It will tell the computer how to process the instructions that are written by you using that programming language. And then the computer gives you back some output.
Let's now talk about the different components of a computer.
Hardware is just the computer's physical body parts you can actually touch. Input and output devices like mouse, keyboard, monitor let you talk to the computer. The CPU does the thinking, the GPU helps with graphics, and memory is where data lives. RAM for a short term and your hard drive or SSD for long-term storage. Let's begin by understanding the von Neumann architecture, one of the most important ideas in computer science. This architecture was proposed by John von Neumann in 1945, and it forms the foundation of most modern computers that we use today. At its core, the von Neumann architecture describes how a computer is organized and how different components work together to execute programs. The von Neumann architecture consists of 5 main parts. First, the input unit. This is how data enters the computer, for example, through a keyboard or a mouse or a scanner. And next is the memory unit. This is where both data and program instructions are stored. A key idea here is that instructions and data share the same memory. Then we have the control unit. So you can think of the control unit as a coordinator of the system. It fetches instructions from memory, decodes them, and tells the other components what to do. This control unit is inside the central processing unit. The central processing unit also consists of the ALU, or the arithmetic and logic unit. It is where the actual computation happens. It performs arithmetic operations like addition and subtraction, as well as logical operations like comparisons. Finally, we have the output unit. The input-output units are shown together in this picture. The output unit sends the processed results back to the user, such as displaying output on the screen or saving results to a file, all those things. And inside the central processing unit, we have another thing, which is registers. Registers are very small, very fast storage locations inside the CPU. They temporarily hold data, instructions, and intermediate results while a program is running. So because registers are inside the CPU, they are much faster than the RAM. So let's try to understand how the flow works. Programs and data are first stored in the secondary storage, such as the hard disk drive or the SSD. When a program is executed, the required instructions and data are loaded into the main memory, that is, the RAM. From RAM, the control unit fetches one instruction at a time and places it into a register. Okay. The control unit then decodes the instruction and determines what action needs to be performed. If the instruction involves a calculation or logical operation, the required data is moved from registers to the ALU. The ALU performs the operation and sends the result back to a register. Once the result is ready, it may be stored back in the RAM or sent to an output device such as the screen or a printer. Input devices like keyboard or mouse send data into the system where it travels through the memory and the CPU in the same way. This continuous movement of instructions and data between memory and registers, the control unit and the ALUs performs a cycle called the fetch, decode, execute cycle that you will learn in your architecture course. And I'm not going into that detail here.
So that was hardware, the physical parts of a computer. Next, let's explore another key component, software.
Imagine a brand new computer sitting on your desk. It has a screen, a keyboard, a mouse, and powerful hardware inside. But right now, it is silent. It doesn't know what to do. That's where software comes in. Software is the heart and soul of the computer. It's a set of instructions that tells the hardware how to behave and what actions to perform. Without software, hardware is just an empty machine. So now let's talk about the types of software that we have. First, we have system software. Think of this as the brain of the computer. The most important system software is the operating system, like Windows, Linux, or Mac OS. The operating system controls everything behind the scenes. It decides which program can run, how memory is used, where files are stored, and how tasks are shared among hardware components. When you open an app, save a file, or connect to the internet, the operating system is quietly making it all happen. Next comes the drivers. Drivers are special pieces of software that help the operating system talk to the hardware. For example, when you print a document, your printer doesn't understand Windows or Mac OS directly. The printer driver acts like a translator, telling the computer how to communicate with the printer. Then we have firmware. Firmware is software that lives inside the hardware itself. It controls the most basic functions of a device, like the code stored inside a printer, a keyboard, or a router. It is permanent and works quietly in the background every time the device is powered on. Now, finally, we have application software, or simply apps. These are the programs you interact with every day. You use the games, the web browsers, Microsoft Word, what else? The mobile applications, all those things. Applications sit on top of system software and rely on it to function. So when everything works together, system software, drivers, firmware, and applications, the computer becomes useful, powerful, and interactive. So if we have to sum up, software is the logic that brings hardware to life.
To sum up what we learned today, we learned what is a computer, what is a program, what is a programming language, and what are hardware and software.